This is a beginner's guide to setting up your ESP32 development board. And when I say beginner, I mean me. So if you're an IT person, you should probably stop watching because this video is going to piss you off. But if you're a beginner like me, you might learn something. First, we're going to install a driver so that the computer can talk to the board. Then, we'll use Python to load the board with MicroPython. Finally, we'll use what's called a terminal emulator to write code onto our board. In order for the computer to actually communicate with the board, we need to install a driver. Hit the Windows key and type Device Manager. Now, plug in your ESP32 board into one of the USB slots. Look for whatever new device pops up, that's your board. In my Device Manager, under Ports, I see something called CP2101 USB to UART Bridge Connector. And if I look on my board, I see a component that's labeled Scilab's CP2101. Google any combination of those words plus the word driver. And here we are at the chip manufacturer's website, Silicon Labs. Go to Downloads, pick the Universal Windows Driver option. Once the download finishes, run the installer. My system is 64-bit, so I pick the one that ends in 64. Now, in Device Manager, our device shows up. This is followed by the serial port. For me, it's COM3. Yours might be different. Remember that number for later. We're going to need it. Now that the driver is installed, our computer can communicate with the device, and we can get it set up to our liking. For this job, we are going to use Python. Go to python.org and download the latest version. When the download completes and the installation options come up, check the box that says Add Python to Path. This will make our lives easier later on when we are using Python in the Windows command prompt. Instead of having to tell our computer where the Python commands are coming from, we can just type the commands and Windows will figure it out because it's in the path. Python has some helpful tools that we will use to set up the microcontroller, but Python's too large to actually run on a microcontroller. That's where MicroPython comes in. Go to micropython.org, download, then scroll down to Generic ESP32 Module. Here you're going to have a lot of options depending on your specific hardware. I think that the generic version 3 will work for most, but if your device has extra features, then maybe you'll pick a different version. In any case, pick your choice, then download that file to somewhere convenient. I put mine on desktop. The next step is to take our microcontroller, erase whatever junk it came with from the factory, then load it up with MicroPython. For this, we are going to use some tools that came with Python, and we're going to do it in the Windows command prompt. This part's exciting, makes me feel like a real computer person. Hit the Windows key, type CMD, hit enter, and you are now in the command prompt. Remember earlier when we were installing Python and we selected Add to Path? Here's where that comes into play. Since the Python commands are in the path, we can simply type in Python commands and Windows will figure it out. If Python was not added to path, we would have to do a lot more typing. Type pip install ESP tool and hit enter. Pip is the package installer that came with Python. It's basically a tool that allows you to install other tools. The MicroPython website recommends that we erase the flash on our board prior to installing MicroPython. So let's do that. Plug in your board and go to the command prompt. That's Windows key, CMD, enter. Now type esptool.py space -- chip space ESP32 space -- port COM3 space erase _ flash. My serial port is COM3, but yours might be different. The ESP board is now a clean slate and it's time to install MicroPython. The MicroPython bin file has a long, ugly name that I don't want to type out. So go to your desktop or wherever you saved it, click on that file and hit F2 and Control-C to copy the whole name. Now when we go to the command prompt, we can use Control-V to paste it in. Now, I could bore you with a long-winded explanation of what to do next, but it's pretty complicated and I can't figure out how, so you should probably just watch along with the video. You need to change your directory to be the same as the directory. God, what was I thinking when I wrote this? You're in a directory. The MicroPython bin file is in a different directory. you need to be in the same directory. You can type dir to see what directories there are. If you see the directory you want, type cd and then the directory name. So to go to desktop, type cd desktop. To go back a level, type cd space ... And to clear all this junk off your screen, type cls. Once you're in the correct directory, that's the same directory that your MicroPython bin file is in, you'll type out the following. Oop, missed a space. That's better. Congratulations! MicroPython is now installed on your ESP32 microcontroller. The MicroPython website recommends using something called Read Evaluate Print Loop, REPL, or a terminal emulator called Teraterm. I didn't have any luck with the REPL, and the Teraterm website looked pretty crappy. I saw another tutorial where the guy recommended PuTTY. I looked into it. This seems like a really good option. It's been around since 1999. It's free, it's open source, and the developer is still updating it recently. Go to PuTTY.org to download and install PuTTY. Open PuTTY, and under connection type, select serial. Enter in your serial port and speed, 115,200 baud. That's 115200, or 115,200 bits per second. Although a second ago we used 460,800 baud for our speed, and that worked just fine, so I don't know, play around. At this point, you should stop for a minute, look around at what you're doing, and reflect on the fact that your ancestors lived in caves and worshipped the sun. Alright, click open, and we are in. MicroPython is now installed and actually running on your microcontroller. That tiny board is interpreting and executing those commands. My board cost $12, and everything else in this process was free. So to me, this is just amazing.